Mein Deutsch ist nicht gut genug für eine Präsentation. So, nächstes Jahr vielleicht wird es besser sein, aber ich muss diese Präsentation auf Englisch machen. So I'll switch to English now. I wish my German was better, but it isn't. I'm here to talk to you about cloud architecture deployment. It's a Kognitio checklist, and I'm here to talk largely about the flexibility that's available, certainly for an environment. Have I got that wrong?
You might have to stand a little bit back.
It makes a good noise. Thank you. So the first question I'm going to ask, and I always ask myself, is the cloud just more business couture? Is this a fashion? The way that customer relationship management, business performance management, process outsourcing, and business intelligence as a whole was. And I guess the answer is yes, but. Because there's been quite a lot of established work done around ASP models, managed services, business process outsourcing, software as a service in its own right. I think the new element that is driving the questions that we're asking is around virtualization and flexibility, and I'm going to use this section this session to talk about the kind of questions we're asked in order to make the most of that. So one of the issues that we've got at the moment in the past has been this vast growth, and I'll talk a little bit about my company in a minute to give you a context as to why I'm showing you this graph. Is that massive growth in data that we're seeing at the moment. Just outside today, I've had people coming up to me and talking about the huge volumes, terabytes of data that are being generated on operational systems from the web that are being generated for images, for example. And the amount of analytics, the increasingly complex analytics that is coming to the fore as we have become more sophisticated at being able to use the data, particularly in terms of predicting our operational costs, in terms of predicting scenarios, in terms of automating our operations. We need to have the analytics to support that. And the model in the past has been to buy big chunks of hardware, which the performance of which degenerates, and then we buy some more. What we're trying to do is replace that, and we can do that now with the cloud, particularly in terms of joining the performance and aligning it with the risk and cost, so we don't have to make huge investments up front. So with that in mind, I was very pleased when I was hunting around the internet in preparation for this presentation to find that these were the issues that people wanted addressed by the cloud, and particularly around big data as well. We'll come back to that. Cost savings, everybody wants cost savings. Faster, better scalability, switching from capital expenditure to operational expenditure, and far easier maintenance come right at the top of the list. The others are largely derived from that. But so that's driving a lot of what the questions are that we are asking, and I have to give this presentation in the context of what people are asking my business in order to say, how should I configure the cloud, what should I be using, what techniques, what tools are available. So I'm going to start with a definition and simply say cloud computing is a model for enabling openly available, convenient, on-demand network access to a shared pool of configurable computing resources. It's a lot of words, but it does say it all, and somebody's spent some time. Importantly, that can be rapidly provisioned, if not instantly provisioned, and released with minimal management effort or service provider interaction. And that's what we're getting asked for, businesses coming to us and say, I've got a problem now, fix it now, please. So then you've got the issue of, right, well, what kind of cloud do I want? Do I want a private cloud? Do I want a community cloud? Do I want a public cloud? Do I want a hybrid cloud? And then they're asking the question, is it software as a service that I want? Just that? Can I start my business on that? Is it platform as a service that I want? Is it infrastructure as a service? I'm going to assume, maybe wrongly, that you're familiar with those terms, but just as a very brief run through them again, this is absolutely running your applications and business processes online. This is absolutely about providing yourself with an infrastructure platform to configure in order to be able to build yourself an operating platform. And this is all about just providing the hardware infrastructure networks, test and dev environments in order to be able to build out an operation in the cloud. Now, I'm going to run this session all about the questions that have been asked for us around platform as a service. Why? Because I know a lot about that, because that's what we do, and because my company sells effectively a database system, a relational database management system. It's an analytical platform. And I can really tell you about what I know about in this area, because these are the sort of questions that people are coming to us and how we are driving them onto the correct solution from all those different flavors and those different versions of the cloud. The qualifications for us doing that is all these multicolored logos. And importantly, I'll draw attention to just two of them. BT have been around with us, British Telecom have been around with us for 12 years, running a service whereby they provide us with all the telephony data, all the telephone calls in Britain every single day, and we analyse them all and compare costs and do some cost comparisons and pricing comparisons for them. On the other end of the scale is Give As You Live, as a new business working on internet charity giving, but it drives revenue from what it charges retailers for bringing customers to them, but it's all internet based. All the data is coming off web traffic. They have spikes and troughs of movement, and they need to be able to have a platform to support that. And there's a very different scenario, architectural scenario and service scenario required for that. The others all operate services with us as well. What we've had to do in response to that, we used to have just a private cloud environment, which we called effectively a managed service, really, is what it was. And we've had to add to that the public cloud in order to take advantage of the architectures from Amazon Web Services. Actually, Savis have got some very good solutions around that. I could talk very briefly about Amazon are very good at flexing in the operational environment, up and down very, very fast indeed. It's less easy to use if you want to be able to produce a very large analytical environment and run some of the new technology around in-memory database processing and analytics. Savis have got a very good solution in that area, and they're outside. But where we come from now is we say, basically, how much data have you got? Where do you want it? How long do you want to use the system for? And do you want to, as it happens, do you want any applications to go with it? And just so you know what we sell effectively, just so you've got context for the rest of this presentation, we take a whole bunch of servers, we join them together and make them into a single instance. The data is moved from disk into high-speed memory, and all those processing cores are used on all that memory together so that it becomes a high-performance in-memory analytical platform. That's what it is. And each processor will typically only work on 8 gigabytes of data, even if you've got a petabyte system or something like that. So that's effectively what we're selling. The reason this is able to be done now, and the reason that you're going to start being able to take more advantage of this more in the cloud, is the complete collapse in the cost of RAM, which has come down from $367,000 in per terabyte in 2002 just to 5,000 now. I mean, this is huge, and of course that means that those infrastructure as a service providers can now provide you with platforms to do this, and that's just in time for the volume of data that's being driven out of web environments or internet-based businesses or new operations, and a lot of that data wants to be analysed. So what is the checklist that we actually go to customers with in that environment? We always start with what do you need to achieve? we then ask them to focus on the particular benefits that they're trying to get from the cloud, not from their analysis, from the cloud. That there is a big distinction in terms of what in-house benefits, what am I going to take, what do I not have to take from the services available. That has an impact on pricing options, and I'll just run through that in a minute. You'll see the differences, and they're quite stark. And in terms of how you manage the contract accordingly. Security is a given. I mention it only because security has always been the thing that everybody worries about with the cloud. And my contention is you really don't need to, but because of what's available. But we'll come back to that. And that's an opinion. It's an opinion only because there's just as many people who can prove otherwise as can prove, no, that's not the case, it's fine. So, it's all about managing the security, being able to manage the security, taking responsibility, seeing what's available. But the key questions always come to us are around availability. The volume of data that you've got to bring to bear, not just for storage, not just for traffic across the network, but also for analytical processing. What is the volume that I need to bring? And nowadays, which hasn't really been a feature of the past, how can I scale that? How can I flex that? Because we're constantly being driven for cost reduction. We're constantly being driven for productivity improvement. So how can I deal with that? And then there's some classic questions we always get asked. So let's talk about the user base, because that is going to affect the platform. What kind of service levels and what kind of applications. So just to remind ourselves quickly, it's cost savings, it's scalability, it's switch from CapEx to OpEx, it's all about easier management. That's what's driving our need, our questions here. And where the database, where the services provided in the cloud need to be separated, just briefly need to be separated. That is an architecture drawn up for a bank in the UK. It's a genuine one, and it supports customer management operations. There's an operational data store, there's an analytical database, and there's a transactional database. And clearly, we have to very, very quickly determine which of these platforms, indeed we might want to cover both, do we want to be able to support. So what do you need it for? Application processing is going to be all about being able to get very flexible volumes of online transactional processing capability. AWS are famous for that, and when I went to see their presentation, blimey, must have been 4 years ago in Amsterdam, and they were just expounding the beginnings of AWS. They were talking about American websites that were needing to flex as content went viral, and it's all about being able to support that. It's about being dynamic, and it's also about being high single transaction volumes. At the same time, and these are just examples, there are other applications for which you need it. Real-time reporting is still about a lot of online transactional processing, but also analytical processing in that environment in order to produce dashboards. Now, that has a different impact on the architecture required, and I'll come back to why in a minute. And then finally, there's the analytical batch processing, which is where I sit. I know far more about that than anything else, which is solved through platform as a service. And we will typically talk to people and say, where do you want to sit? Are you wanting to do real time? Are you wanting to do analytical batch processing? If you want to do application processing, we need to send you to someone else to look at that. Because it's all about being able to get yourself a capacity to support that analytics. And so we'll talk to them about what business processes have we got to support. The sort of business processes will be huge in variety. And some of them point solutions, some of them are not. I just want a row column report with some nice diagrams on it from MicroStrategy, please, through to basic statistical analysis, deep data mining and clustering, up to self-learning algorithms that can make predictions as transactions are going through on the system, and therefore managing dynamic content back to the customer and doing learning all the way through. So we always start with this. Where do you want to go, and what are you going to support? And then we say, well, great, But what's the user community on that? Because as an analytical platform, it quite often has to support not only high complexity, high volume, but also high frequency, high usage. Now we get a lot of demand spikes happening, especially if we're combining a platform that has both got power users and mining applications, but at 9 o'clock on Monday morning when the sales figures or performance figures come in, everybody hits that system at the same time, and we need to be able to support that. So we look to be able to find what are the analytics going on. Can we put that all in one system? Do we have to partition it? And I'll talk about partitioning strategies in a bit. What's the scheduling capacity and what's the volume of users, and build that mix into a service level, if you like, a service level to support that. Okay, so assuming you've decided that, you understand that, you understand what is the capacity that you're looking for, you're understanding what the profile is that you're looking to support, you're looking at the number of users to support, you'll then need to focus, and we find this a lot, people come to us and say, okay, I've now got I've got a performance criteria, I've got a solution to support, but really what will it bring the business for me, and can I support that better internally? So we will typically talk to them about comparing this. Now, on my screen it's orange, on yours it's blue, but this is fundamentally, this was taken as looking at a number of different services that we operated and where we actually found the benefits came from the client. This is really what they called for. Service level control is something that's equal both in-house and out in terms of outsource. The reason for that, quite simply, is that you're asking an outsourcer to take on board your risk. Therefore, they charge a premium for it, but then it's quite an expensive operation to run anyway. The big benefits are coming from CapEx, budget, and implementation costs, simply because the architecture is in place and can be used and you can simply deploy it. I did toy with the idea of running you up a database right here, right now on the internet, because I can do that. I can put you in place an analytical platform in no more than 20 minutes flat. And obviously that's playing to that benefit there. In terms of the budget control and the systems management costs, because of the flexibility, well, here it's shared resources. It's the fact, the ability to, we have people who are managing multiple resources, so it's obvious that it's going to be a reduction. But here the budget control is because people now can flex their usage. Flex the usage models of data available to them. They can buy packages and use them for hours per day, or short-term contracts or longer-term contracts. So that's clearly what we're looking for. And typically, if you optimize it all correctly, you should be seeing about a 38% improvement in the cost base as a result of that, if you optimize it correctly. I think one of the most interesting things, though, was doing the price trade-off. And this is genuinely taken. I priced a terabyte system on a 6-month private cloud versus a public cloud, and 1 year's service, and I compare the two, and it's very obvious very quickly that, you know, for short-term projects where your usage is only a few hours a day, because it's project-based, you're going to get a lot of cost benefit from being able to support, being able to use Amazon warehouse services. And these, by the way, on demand, light reserved, medium reserved, and heavy reserved are all terms used by AWS, and it's very effective in terms of saying this is contracted terms but limited usage, and this is absolutely on demand, whatever you want to do. Whereas the private cloud, you contract for a given period of time, but you can be charged only for a certain amount of usage if you choose not to use it for a period of time. However, when you move to a year, you can see suddenly the on-demand goes through the roof. The medium and reserved instances stay more or less where they are. But it's starting to make it very clear. Shorter term, smaller volume is where the public cloud comes into its own. And just as an example, I've shown it here, where I just took exactly the same scenario, but I made it 3 terabytes instead of 6 terabytes. The costs are very much closer in terms of the on-demand usage versus the private cloud, because of the dilution of the hardware. And once you've gone for a longer term service on larger volume data, then that is where the private cloud is coming to its own. And now, as I say, I have no axis to grind, I don't care. We offer both. But it's clearly those questions you need to be asking. How long is my project? Where can I get most of my benefits from? So let's move on briefly to security. Now, security levels, I mean, they're a must-have anyway, because we all want our customers to be happy and come back. But the European Data Protection Directive made it very clear that we've got to collect data and it's got to be secure from abuse. So how do I manage that? How do I make sure that's happening? Well, I say it's largely an emotional issue. And it's an emotional issue because the sheer investment that has gone into unauthorized access, prevention, data theft, rogue user abuse, data in transit, physical security, all of which we expect to explode our systems and destroy them. There are so many applications in the cloud that enable that not to happen. Tier 3 data centers is the classic starting point. Nobody can get physically in. VPN, SSH access control, we use that. We're very, very tight on that ourselves. System monitoring, dual system monitoring between ourselves and our clients. Data encryption can all be brought to bear. And if you want to have a look at some very good examples, just go and have a look at Amazon security, Rackspace security, or any other security. They've all got the appropriate standards, certifications. They've all got the systems that you can apply. We would even dare to say that because it's their business, it's much harder to get into their systems than perhaps some of our clients' systems beforehand. We'd never tell our clients that, of course. In terms of locally what we would do and where you can take control, the sort of areas we do typically ask this. There's one going through just at the moment, where people want the condition of data in transit, data at rest, data in process. Where are they must be secure in all three environments, and how do you manage that? We do it through VPN, PGP type encryption, file level encryption on the data sources, but when it actually comes into the managing the environment itself, we are willing to give away the root level admin for monitoring, the Linux admin for managing the software, the user privileges, and the SSH fixed IP management. We will continue monitor and control. We will always continue to monitor and control and to alert. What we won't give away is the, where is it supposed to have, probably because I'm not pressed the button. There you go. We won't give away the actual management of the server farm itself. We need to be able to control and manage access to that. But because we have had customers who've come to us in the past and said, no, I really need to make sure that none of your system administration people can get onto my system and therefore touch the data, even if you do go through the appropriate certifications and security procedures. So this is all available and can be dealt with, but you can ask the questions, very granular questions around it. Okay, so the real hub and the nub of this is why do we use the cloud is for availability, volume, flexibility and scaling, getting that user base and workload managed. And I think what we see is in the past, if you had a data volume, you had to buy a capacity for a data volume in order to analyze it. You no longer have to do that. Now you can buy a data volume of storage, which is incredibly cheap, and you can then do the analytics on it according to that data which you wish to analyze. Buy the capacity for the analysis, not the capacity for the volume. It is possible. I'm going to show you a couple of architectures in a moment how we've done that and some use cases of how that works. But you can see that there's difference here. You can usually quite often predict in an analytical environment what's the persistent data that I need to hold in storage versus what I need to analyze. And I don't want to have to buy a capacity for all the different schemas and data structures for each of those analysis. I just want to have one capacity and be able to reuse that. Versus, in fact, your analytical environment becomes very similar to an OLTP memory usage, which is based on the demand and usage of the system. So it's all about understanding the usage pattern, managing to demand, and then purchasing the capacity for storage and processing separately, which is now very much achievable. I'll give you an example. This is a typical system that we use. So you've got data sources coming in, you've got a persistent data store environment, possibly disks on the servers themselves, possibly a storage area network, possibly in some cases a Hadoop environment where the data is. What you need to be able to do is pass that data into the memory environment so that the analysis continue to take place, and you pay for the capacity in use at the time. So it could be going up and down on a regular basis, and you can meter that. Somebody asked me a little earlier on when we were sitting outside, said, oh, so I bet everybody buys that one, don't they? And I said, no, they don't actually, because that carries a premium, being able to go up and down like that. But once you've worked out a standard pattern of analytics, you can then continue to buy to that. But it does mean that you can store increasing data, never throw it away, keep the minute granularity that you want to use, and that's what modern data analytics is all about. It's all about getting fine granularity so that you can completely understand process issues, predictive events, and so forth. And then be able to put in flexible systems to be able to look at that with the RAM capacity that's on demand. So that is a typical architecture that's now available, and here is the sort of environment we're being asked to look at now. So just a quick explanation. This would be a cloud environment. In it would have database servers to be able to perform the analytics. Here you'd also have perhaps an elastic block storage, EBS environment. For those of you who are not familiar with Amazon Web Services, EBS is the persistent data layer. You could build your Hadoop environments there, being able to flex those very rapidly to bring in vast volumes of data, perhaps do some processing in order to filter out the data that you don't want to store. And then as that comes through, you can be switching between schemas so that you can get a real-time up-to-date view of your data, and also be able to flex this platform according to what you want to analyze. And that's pretty typical of the sort of things that we're starting to design now. Meanwhile, the client apps, there are two options really. You can either go through an ODBC, JDBC connection direct to the database itself, so your application layer can sit outside. You can keep your existing application layer, or alternatively you can build one into the remote, into an RDP environment. We've actually got hybrid cloud environments where we provide this, and this sits outside, and the other way around actually as well. So you can create persistent data layers independent from the processing, which is valuable for those who want to pay the small amounts for huge volumes of data, and pay small amounts for the smaller amount of data processing that's taking place. You can switch data between the operational schemas. The reason I go on about that is people want real-time reporting, and they want it on very large volumes of data, and they've traditionally tried to do that with online transactional processing systems which aren't able to cope with the volume. What this now means is that you can actually have streaming of data into a Hadoop environment, which can then be, and you can have two duplicate schemas running side by side and simply updating from the persistent data layer on a scheduled basis, and get real-time reporting on literally vast volumes of data for that real-time area, which has been difficult in the past to achieve. Yeah, well, I've told you all about that, rather. The other thing that you can do is about, it's a very, very busy slide, I'm terribly sorry. What it is, it's a lot of instances of a database in one license. Effectively, that's what it is. But you buy your platform. Imagine if you had this platform, And what you wanted to do is today, I wanted to have the contact history quota and the loyalty management scheme, but actually tomorrow, take those away, I want to make the sandpit bigger. And I want to be able to drop, I can keep a library of schemas, I can keep a library of views of the data, and simply pull that in from my persistent data layer and constantly flex that without actually having to change my cost base at all. I can spend my time building that. And then within that same environment, I can keep my application simply pointing at that database instance and picking up, running queries against the data. So again, it's that flexibility that we can now bring into that environment. People are looking for that. Just as a final, as I said, this is a bit like a hybrid cloud environment. This is actually very typical for the smaller volumes of data, where customers are saying, look, I've got a point solution, I've got some particular analytics I want to be able to do. Can you just provide me with a platform where I can put my data in disk and analyze it, and I want to use my existing estate of applications, and then change their mind and say, oh no, actually I'd like to put some new BI apps in that, so we run those up in an Amazon environment. So those are the kind of questions that we're being asked about. It's about being able to say, can you provide that flexibility? Can you partition the system up the way I want it? Can you do that without requiring me to buy additional licenses to do that? And the answer to this is all yes. Can I buy a certain estate and flex it? Yes, I can. Will it support the particular workloads that I've got in the past plus new ones? Absolutely. So just to go right back to the beginning again, just find out what it is you need. Focus on the benefits that you're particularly looking for in terms of surfacing. Security is going to be okay. You know, there is enough out there for you to be able to manage that, manage it yourself, or indeed have a service provider manage it for you. In terms of volume and flexibility, it's the new world. This is absolutely what you can do, but you need to take some time in terms of what architecturally is available to you. So, I mean, I'm sorry that I rushed through that, but it's about, it is the checklist that we use. I'm outside if you want to come and talk to me, but thank you for your time, and thank you for listening to me speak English too.